I'm Mostafa Moradian, as you may have heard by now. I'm a senior software engineer at K6, which is a Grafana Labs company. I am presenting performance testing gRPC services today. I'm mostly or generally talking about K6, but we'll also show a few scripts of testing gRPC services. Um, Yes, so I have a few years of experience. I am a senior software engineer, also a security lead. Been with the company for about 3 years now. My main area of expertise is Python, but I also code in any other language to get the job done. And I'm also still learning. So if you want to reach me out, I'm available on social media and also on my website. So feel free to reach out with questions, with suggestions, feedback, whatever you feel like. Okay, I'm gonna present performance testing in general, and then talk about K6, and then I'll have a small demo. After the demo, I will talk about K6 features. After that, I'm gonna introduce gRPC in K6, show you a few scripts for performance testing gRPC services, and then I will finish my slides with question and answers. So, what is performance testing? Performance testing is basically testing a system to see how it performs and behaves under various conditions, usually under load, to fulfill non-functional requirements. So this is kind of a somewhat cryptic sentence. So I'm going to decrypt it by explaining every single word in the sentence. So first of all, performance testing is a general term that refers to this specific sentence. So load testing, I will talk about load testing a little bit later, but load testing is a way to do performance testing. So they are not equal. Just so you know, while we are doing the testing, we are testing a system. So what is a system? System is we call it a system under test. So in our scenario today, I'm going to be using gRPC bin, which much like HTTP bin is a testing system, um, is a test system for the gRPC protocol. I'm sure you've heard about it. So our system under test today is gRPC bin. To see means to observe, to monitor, to see metrics, to see logs. So seeing is that. How it performs and behaves is basically to see what the normal behavior of a system or the system under test is, and how the behavior under load, stress, or soak testing is, which I'll explain a little bit later. Various conditions are normal conditions. So in a normal condition, you make a few requests and the system just accepts the request, processes them, and returns them back, returns a response. But when you put load, then you see how it can handle that load and see if it sustains the load. A little bit further, you can increase the load a little bit over the threshold and basically stress test the system. You can keep running the test for a few hours and you're soak testing the system. So these are the terms you will be hearing from me a few times when talking in this talk presentation. Usually stress testing is used for putting more load on the system to see if it can handle more load than we expect. And soak testing is used to test the system over a long period of time to detect slowdowns and memory leaks of sorts, if they exist. Last but not least, we have to fulfill some requirements which are non-functional requirements. Our non-functional requirements that we want to fulfill are responsiveness, stability, scalability, reliability, speed, and these kind of things. So, so while we are doing the performance testing, we are basically measuring certain qualities with quantities. So we are quantizing those qualities to be able to test them. So, for example, if we want to measure reliability, we should measure latency, we should measure response time, failure rate, all those metrics, all those indicators for us to understand if our system is reliable enough or not. All in all, it's all about SLIs and SLOs and SLAs. So we probably have an agreement with the customer, the team next door, our boss, or some stakeholder in the system. So this is our SLA, so the agreement. And for this agreement to be fulfilled, like for example, imagine that we have a service, a gRPC service, an HTTP service, or anything, a microservice, a Borg, something. And we want to deliver 500 milliseconds, less than 500 milliseconds for the users to be happy. So what should we aim for? What are the objectives? What are our SLOs? So the objectives we want to achieve should be lower than our SLAs. Otherwise, we will easily hit our SLA like in a few seconds of testing. So, for example, if your SLA is like 500 milliseconds, your objective should be 300 milliseconds. And what you're measuring in this whole scenario, or the numbers, the indicators, the SLIs, are like, for example, latency. So, latency is defined differently in different systems, but usually, how long does it take for the system to process and return a response after you make a request? This is the latency. Uh, it could be other metrics, but this is just an example to show you how this SLA, SLO, and SLIs come into play when you are doing performance testing. Okay, enough with the performance testing. So let's see what is K6. K6 actually is a modern reliability testing tool for developer happiness. I will talk about every single word in this briefly. So it is written in Go and it's scriptable in JavaScript. I'll show you a sample script of K6. So for example, this is a script of K6. I don't know if you can see that very well, but I hope so. So it has a few imports. It imports some modules which are from the K6 API. You set a few options, the number of virtual users, the duration of the test, and you have a default function that defines which requests to make and how to check for them, like the assertions. So you saw this script is written in JavaScript. The syntax, supported syntax is ECMAScript 2015 and ES6. Um, it has an easy to use interface and a lot of APIs to work with it. It's easily integrable with CIs and monitoring tools and stuff. Has a lot of outputs. It is extensible in Go via XK6. So this is K6, the project. As you can see, it's already mature. And this is XK6. So you should use XK6 to build extensions for K6 that takes your extension in and builds it and gives you a binary. So let me, for example, give you an example of that K6. So this is an extension I wrote to load test Kafka. So in order to build this, you just need to uh, install XK6 and let XK6 build the binary for you, and there you have it. Um, Let me just show you in a few. moments how this is done. So for example, imagine this, and then I have already installed XK6, so I just want to build XK6 Kafka, the latest version. I just hit enter, it just goes and fetch the resource and builds the binary for us. As simple as that. And if I just ls into the directory, you will see that I have K6 installed. So it's devel version because we built it ourselves, and then the latest version, almost the latest version. So that's the extension. It is also a GPL license, so free and open source. There you have it. It can be used for load testing, soak testing, stress testing, all sorts of different testing I've told you about. It can also be used for performance testing and synthetic monitoring. And we also have a few extensions to help with chaos and reliability testing. Um, so, for example, we have XK6 browser to do the browser testing, as I told you about it, browser automation and everything. And we also have XK6 chaos, if I'm not mistaken it with something else. Yes, so this is for chaos testing. So an extension to do chaos testing. We also have a lot of things for Kubernetes and stuff if you're looking into those things. It supports HTTP 1.1 and 2. It supports WebSockets and gRPC internally. But then you can have, there are a lot of extensions to choose from. For example, the one I shown you, you can use my extension to load test Kafka, your Kafka consumers and producers. And last, you can also bundle JS modules. It doesn't support browser API or Node.js APIs, but you can bundle a lot of modules that do not use such APIs. If they do, I suppose you can also bundle some because there are shims and wrappers and stuff to deal with those APIs. But all in all, you can bundle a few modules, and we also wrote a lot of modules ourselves. So if you go to the K6 documentation, you will see that there are a few internal modules, how to bundle modules, how to import modules, how to import remote uh, like modules from HTTPS endpoints and stuff. So that's that. So now's the demo time. Let's do a demo. Okay. Let's see what we have here. Okay, so this is the same exact repo that I just shown. So this is the repo. If you want to access the code, this is public. Uh, Let me go back. So I do have K6 installed. You can easily install it. Let me show you how. You can easily install it. You can either use Docker or you can just download the binary. Or there are also like apt deb packages, like apt packages available. So I used apt to install it. So let me see. Okay, six. Yes, there I have it, the latest version, as you can see. Yes. Let me run. Let me first go through the script and then talk about running it. So any script in K6 has a life cycle. A life cycle in K6 means that there are 4 steps in the code. So there is the init code, there is the setup code, there's the default function, and the teardown. I just show you a few of them. So these are the modules you have to import. So this is the HTTP module. By the way, all of these modules are available here. Let me show you. We have the JavaScript API, so you can just go to the K6 API and see all the modules and everything, like crypto, data for using shared arrays, encoding, execution, HTML. So the HTTP, while I say like K6/HTTP, it is here. Like you can like go to the get parameter and see what parameters it accepts and the response it returns. And then for the response, you can just see what's in the response so that you can check if the things you're looking for is in the response. Back to the code. So these are the imports. This is like outside the default function. What is outside the default function is called init code. Whatever you run here will be shared across all the virtual users. So what is a virtual user? I will talk about virtual user in a few after the demo. But uh, what is a virtual user? It's basically a way for the code to be able to initialize something. So, for example, if I go to the gRPC script, you will see that I'm initializing the gRPC client outside the virtual user code, which is here. Why? Because um, I want to share this client instance across all the virtual users. That's why. That's it. And then we have a lot of options to set. Here I just shown two uh, for the sake of easiness. So the virtual users or users, if you want to call it that, I'm going to use 50 virtual users and I'm going to run this test for the duration of 10 seconds. So what does a virtual user do? So a virtual user, um, each virtual user executes this default function or any other function that you define. I will talk about it in the scenario section. And we'll make a few requests. Here I'm showing HTTP requests. So I'm just like initializing a variable to receive the response. And I'm using get to get the test server of K6. And then I also imported check. So check is a way in K6 to assert responses that you get from K6. For example, we are asserting that inside the response, the status is 200. Okay, you can assert many things. And unlike assert, it doesn't stop the test from running. It just records the number of time it succeeded the assertion and number of times it failed the assertion. So the difference with assertion is that. So let me just save this script and run it. Okay, okay. If I run K6, you will see the commands it supports. The available commands are here. You can play with them, and there are a lot of flags. So in order to run this, I just say K6 run HTTP script.js. Um, then we see that the logo is printed, a few execution context variables, the scenario that it is using, and then you will see the progress. You've seen it, it's done. And then you see this message. So you see a green message because basically this check verified that all the requests that we sent had the 200 HTTP status code in the response. And then a lot of other metrics. So we have sent here I can show you we have sent 5,006 requests in just 10 seconds with 50 views. We've gone through the default function 2,500 times. So this is called iteration. So the number of times this loops keeps going. So per each loop, this code is executed, which is called an iteration. And then this is the amount of data we received. This is what we sent. This is the time it took for the HTTP blocking to receive the data or to send or whatever. This is the time it took for connecting while sending the request. This is the total duration, including connecting, blocked, receiving, and sending, and TLS handshake, and probably waiting, if I'm not mistaken. Um, yeah. And yeah, the expected response, we expected response from all of the messages because we basically checked for the response. We had the option to discard all the responses, but that's another topic. That's for testing under huge amount of load. For example, millions of requests per second. Then you don't care about the response because you're bashing the system. And then, by the way, you can visualize all this data and send it to InfluxDB, Prometheus, and a lot of StatsD, Telegraph, and other system. Uh, this is the total duration of each iteration took to send those requests. And these are the number of views and views max. So we used all the virtual users in the pool of virtual users we had. That's that. I will answer the questions after the talk. We will have a Q&A session. Okay, by now you've probably seen a lot of features of K6. You've seen the test lifecycle. I just shown you. There's the init default function, view code we call it, and then options and imports and the teardown. So I didn't show you the teardown because it's not needed for HTTP. You've seen a lot of metrics. These are the metrics. These are the built-in metrics. You see, these are called built-in metrics. And then you can also have um, custom metrics. K6 support 4 different types of metrics. So counters, gauges, rates, and trends. And you can import these metrics. You see, like you want to have a trend. And then you import it and you add, for example, your timing of your request, the response of your request, and then record these, and then send it somewhere, like for example, like this. You see, it records everything. You can also tag those metrics, and these are the metric types supported. There are also checks that I talked about. So assertions, basically. If I go back. Okay. There's something very interesting, at least for me, to support something called thresholds. So these are pass-fail criteria. Basically, in a few slides ago, I shown you that we need our services to be responsive under 500 milliseconds. So this is how you set those thresholds. 300, 500, all these thresholds are set on the script using thresholds that is supported in K6. And this is the syntax. In the options, if let me go to my own script. So yes, so gRPC request duration is an internal metric for recording the duration it takes for a gRPC request to, be invoked and then receive a response. We created a threshold in the options, and we said, okay, we want the threshold, so P59, so 95% of requests, or basically, we allow 5% of the requests to be above 300 milliseconds, and the 95% should be always below 300 milliseconds. We also set this to abort if there is more than 5% of failing of thresholds, and we give it 1 second to 1 second delay to abort the evaluation because it takes time for this threshold to be calculated, because basically it takes time for the request to go and a response comes back. especially if you're making a lot of requests. And then I also set another threshold to say the you've probably seen this five nines. It's a very famous one. So we say the five nine of system is this. So you can say that five nines should be less than 500 milliseconds. So that's about the thresholds. And then there are modules. I've already shown you a few, but I can also show you a few others. There are JS libraries provided by us, like expect, HTTPX, chai.js recently released, and AWS also recently released. For example, with this AWS library, you can access S3 and access your buckets and storage and stuff. You can also store secrets in Secrets Manager on AWS and retrieve your secrets from there instead of passing it in the script, and a few different things. Also, there is the chai.js, chai assertion library. The port of it for K6, you can use it to do BDD, TDD style assertions. For example, you import this to describe and expect, and then you set a threshold and say, okay, describe this, the response, and expect the status to equal 200. This is how BDD works, behavior-driven development or test-driven development, whatever. And this is how you have the thing. So it internally uses check to expect. K6 also supports tags and groups. So you can tag your metrics while you're sending them to you can tag metrics, scenarios, groups. You basically can tag everything, almost. Yeah, and tags are very helpful when you are using a monitoring solution. Um, so you can like send a few information, like anything that you can tag on your metric, and then filter your metrics on your monitoring solution by using these tags. Then there are groups that you can use to group requests and then have them tagged all at once. And then there's a new metrics added called group duration, uh, which is how long it takes for the whole group of requests. For example, you are testing your uh, um, login microservice. So you group all the endpoints in one group, and then it shows you how long it takes for you to send a login request, receive a response, and then send another request to verify the user, for example, or send another request to verify the profile of the user or do something else with the profile. There are a few system tags like URL, name, group, check, and stuff. And you can also define your own tags like this. When you're making a request, you can like say that, okay, this is my tag and this is the value of my tag. And this will be shown on your request. Let me just quickly show you how it works. Let's see if I can. Yes, I'm a tag. Oh no, you can tag everything. If yeah, hope this is correct. Let's run the script again and see what happens. You stop the test. Uh, okay, I stopped the test, so everything is gone into haywire. But the tags are applied. I'm pretty sure. but they're not shown in the CLI as far as I know. Anyhow, let's go to the next feature. The next feature is scenarios. Scenarios is a way to describe how you want your load, uh, because K6 has a few executors to share iteration, to share VUs, to do constant request rate, to do constant arrival rate, to like buffer request if the system cannot handle it, and so on and so forth. Uh, you can use this to define a few scenarios, for example, like this. For example, here we have two scenarios, and each scenario starts at a certain time, and it does something at that time. So that's that. Then you also have access to environment variables. So K6 can accept environment variables on the command line, or you can include your system environment variables, and you can deal with a lot of configurations. And you also have access to execution context variables, which are basically what view are you running on, what iteration are you executing, and stuff. To the good part. So for testing gRPC, K6 has built-in support for unary requests. The support for event loop is added in version 37. Now it's version 38.3, but we are slowly but surely moving towards adding streaming and all those protocols that need this streaming and event loops and stuff. Uh, we would be very happy to see your contributions on issue number 2020, which is support for gRPC streaming. Um, yeah, that's that. And let's go see some demos, some more demos. Okay, for the sake of this demo, I just use gRPC bin. So let me show you. Yeah, so I just cloned gRPC bin. It is also a submodule in the repository. I am like I've stored these scripts on, and I've already built this thing, but I can build it again. Nothing fancy happens other than building a binary, and you can run the gRPC bin, which is a test API like this. Let me just quickly show you gRPC bin. Yes, this is gRPC bin for those wondering what it is. So it's a test service like HTTP bin, and it has a few services, and you can use it to test over insecure and secure gRPC. And you can use Docker to run it, but since I have Go installed, I just built it and just ran it. And what I'm going to do is to first explain how the script works in terms of gRPC. So we should first import gRPC from the net module, net gRPC module. And then we also import sleep from K6. I'm using sleep basically because um, normal users have some delay in, like, for example, clicking on some button and then like scrolling down and clicking on another thing. So sleep is used to wait, Um, that's that, so that you don't bash the system like crazy. You should initialize the client, the gRPC client, and then you should load from this directory the hello protocol. So let me quickly show you. So this is also available as a submodule. So the hello service and the hello protocol. So as you can see, there are four uh, endpoints, I would say. This we are interested in say hello, which is a hello request, is an optional string greeting, the first field, and then it returns a response, which is a required response, and the field is called reply. If I go back, yes, uh, I'm gonna use 5 views for now and the duration of 3 seconds just to show you how it works. The default function here, you see, it's a closure. In this default function, so every virtual user go through this loop. So it connects to this address in plain text, and then there is some data we want to send, and then we invoke this endpoint, which is say hello in the hello service with this data. So a unary request to just receive something. I just wrote, I use console log to see what's inside the message for demonstration purposes, but it is not usually recommended to console log while you're testing a system because it generates hundreds of thousands of messages per second, and your system will be unresponsive very quickly. And then I should close the client on each iteration. I can just do the close on teardown, but I just keep to this example. And then I wait. I send a request, receive a response, and then wait for 1 second. Okay, let's go here. K6 run gRPC 1, and let's run it. Okay, 5, 5, 5. Okay. You see 15 lines, basically because we are running for 3 seconds and we have 5 virtual users. So 3 to 5, and we are waiting for a second. So each second we are sending 5 requests from 5 virtual users. And this is the amount of data that we sent and received. This is the duration it took for the gRPC request and response. So the average is 903 microseconds, the minimum, median, max, P90 and P95. Each iteration took 1 second exactly, kind of obvious. And we iterated 15 times because, like, 3 seconds, um, each iteration, 1 second, 3 to 5, 5 views is 15. So that's that. Now I'm going to show you a slightly more advanced script that uses a few other options. So I'm using a metric, a rate. I'm introducing checks, groups, the slip from K6. I'm not using, I'm not loading the protocol file because protobuf files because I'm gonna use reflection for the server to decide what I'm sending and serialize and deserialize based on that. I also introduced, okay, so we are using 50 virtual users. We are going to run for 10 seconds. There are 2 thresholds that I've already shown you. For the request duration, I want the P59 to be less than or equal to 200 milliseconds, and abort if it goes above. I'm gonna set it to something that fails. Like, I know that it will fail on 10 seconds. Fingers crossed. And yeah, P59 is less than 500 milliseconds. I introduced a rate for the number of requests. So it records, okay, I will explain the rate a little bit later. We are making the same connection. We are grouping our requests, and we call the group say hello to Bert. The data is the same. Per each loop, we are having our own loop that creates 100 requests. it invokes the say hello 100. This is not needed. You can use virtual users and iterations and stuff. I'm just showing for the demo purposes. I'm just showing so that you can have an idea of how we can hit a thresholds. This is definitely not needed. Just let K6 do the job for you, increase the number of views and stuff instead of doing this. This is an anti-pattern. Don't do it. So this is our rate metric that I've just initialized here, and I'm checking if the response here, the status of the response is okay. So it records the number of failed and succeeded requests and show us at the end. And then I also check if the response status is okay. That's a separate thing from the rate metric. And I also check the message to see if the reply that I've shown you is hello Bert. It also checks for data type and stuff, but that's out of the question. You can introduce sleep per request. So 100 sleeps, that's not a good idea, probably. You can introduce sleep per group. And then at the end, you can also sleep per virtual user, per iteration, I would say. So then I will close the client after making these many requests. Let's run the test and see if we can hit the threshold. Yes, okay. And there we go. Okay, let's wait 10 seconds. I hope it fails. Doesn't, so that's that. Ooh. Okay, wow. The request duration was so fast, it didn't fail. The average is 1 millisecond, so I should go below millisecond or increase the number of virtual users. So let me increase it to uh, 5,000 virtual. This is not a good idea if you have a huge script. Yes, because it uses a lot of memory. I hope my system doesn't crash. Fingers crossed. Okay, it took a few seconds to. Yes, there we go. I managed to fail it. Okay, we have 5,000 views, not 500. I mistakenly said 500, maybe. And it took 3 seconds to bash the service and get a response that is above 10 milliseconds. Okay, that's it. And yeah, the P90 and 95 is like 2 seconds. So that's huge. That's way above 500 milliseconds and also even 10 milliseconds. Um, yes, that's that. Let's go back. Yes, it concludes my presentation, and I am happy to answer your question. And thanks for listening.
Thank you, Mostafa. Thank you all for being here. And please, if you have any question, please. Okay, so Paul, please go ahead.
That was an accident. Sorry.
No worries, no worries. I'd be happy to answer your question. By the way,
Do you have any question, Paul? Okay, so Milty
thank
has
you. Thank
one.
you.
What a wonderful presentation! Looks like a very interesting tool.
Indeed, indeed, of course.
And let me see if there's anyone
If
who would
if
like.
you, if you want to know more about K6, you can always consult the documentation. But we also have a K6 community call. The last one was on last Friday with Paul, Leandro, and Mihail. We joined together to answer people's questions live. It's on it's on YouTube, so just follow there. And I'd be happy to answer all of your questions even after the meeting.